Hello friends. Today we are gonna do symbolication of user space programs, and specifically I would like to have these backtraces that show up sometimes to contain user space program symbols. So like this for instance was the terminal exiting, and every process will do a backtrace when it exits, just because if it exited for some reason that was not good, then you can look at the backtrace to see how things ended. And you can see here that the kernel symbols are already automatically symbolicated, but the user space program is not. So let's just get right into it. So the way that we currently load programs is that everything is statically linked, and the process doExec function here takes the path and then creates a VM object here for this file. And the VM object is like it's like the base object in the memory management code that is either like an anonymous mmap type allocation, just like arbitrary memory, or it can also be an inode. So if you're mapping a file, for instance, and in this case, it's an inode VM object that we use for loading programs. And then what we do here is that we create a region object around this VM object, and then a region is the unit that you can actually map into a process's address space. So I think what we do here is that we create a region with this VM object here, and we create one for the whole executable, and we just keep it around with the name executable. So I think actually I can show you what it looks like in a process address space. If we look at like, let's see, this terminal is 8, so we just look at address space for 8, and you can see the executable region up here. It's the very first region. And that's the whole ELF executable. Of course, it's not eagerly mapped into memory all at once. We just load the pages on demand as we need them, which is fine. But what I wanted to get to is that here is the ELF loader, and this is the object that is responsible for parsing the ELF headers and parsing all the sections and stuff, and actually mapping the file at the right place in virtual memory so that we can run it. So the thing is that this thing here is on the stack during doExec, and then it goes away, and that means that we lose all of this interesting information, like where the symbol tables are and stuff like that, stuff that we would need to symbolicate the backtraces. So I think what we're going to do is that we are going to actually keep this around in the process. So we'll do something like make elf loader, and we'll keep this in an ownputter instead. And then, oh yeah, we gotta change all those dots to that. And then we can save it in, say, melf loader, and then we'll keep that object around in the process. We should save this region too, or well, no, we don't need to actually, because we already have the region. It's named executable, so we can find it by name if you wanted to, but we won't even need to because the elf loader is already pointing straight into that region. So as long as this region is alive, which it will be for as long as the process is alive, we can use this elf loader. So let's see, let's add that thing to process.h private, and we can just put this at the bottom here. Retain putter, no, own putter, elf loader. Okay, and let's have a way to access it. Elf loader. Now keep in mind that not all processes will have an elf loader. For instance, like a kernel task is not going to have an elf loader because it won't be instantiated from a file. So that's why we need to have it be a pointer and not a reference. Okay. And then, now that we have that, I guess we should have something like a string, symbolicated, the word address, and the elf loader, so that we can give it an address and it will tell us, it will just give us the name of the function if it's, if it's inside the self loader. And let's see how we would use that. So here is the dump backtrace implementation. And basically, first thing that it does is that it just walks the stack and finds all of the symbols that it's interested in, so like all the return addresses along the stack, until we get to a null pointer, and then we accumulate those. And then here we loop through the ones that we found and see if we can find a kernel symbol for it, so ksim. In this case, we're probably going to be here because we don't have a ksim for user space addresses. So we could do something like current process elf loader. This, and if we do have an elf loader, then we can print out current process elf loader symbolicate symbol address, and we need to elf loader, and what's wrong with this is that it returns a string and we have to get the characters. Yeah, I think that's cool. So let's go and implement this thing. Where the hell did I go now? Okay, so this is the function we want to make. So elf loader symbolicate. I guess we'll put it here. And what's it going to do? So one thing that's important now is that the elf symbol table is not sorted, so we're gonna have to sort it. So let's say if m sorted symbols is empty, then we'll make the sorted symbols. That should be struct sorted symbol, keyword address, const char name. So it's nice here because we just need to save these two things for each sorted symbol because the strings are already inside the binary. So we don't need to like copy them out or anything. We can just point directly at them like this. Let's say m sorted symbols, and I guess this should be immutable because we are gonna create it on demand here in a const function. So then let's iterate all of the symbols in the elf image and say auto symbol that. I don't know why I'm putting a comma there. Yeah. Okay. M sorted symbols dot append symbol dot so it was the address and then the name. And I guess we can actually what's that, ensure capacity because we already know beforehand how many we're going to append, so we can make sure that that space is already there. That way this vector append here doesn't have to reallocate as it goes, because it will just be a single allocation. That's pretty nice. And then finally we're going to have to actually sort it, because now it's unsorted. So let's include quicksort, and we'll say it was sort m-sorted symbols begin, m-sorted symbols end, and then we need a less than function, so I guess we'll just make a simple one, like a.address is less than b.address. Okay, so now we should have the sorted symbols here. So then let's loop through them. I is less than sorted symbols, that size. We'll say if address is greater than m-sorted symbols. Well, no, it's always going to be until we find it. So address. So if we passed the address, then the previous symbol was the right symbol. So I guess if I is 0, then we can just return something like that. Otherwise, let's say symbol is m-sorted symbols I -1, and we'll say return string format plus the offset. So that would be symbol.name and then address minus symbol.address. And if we don't find anything, we'll just do that. Well, it's a lot of programming without testing, but let's see how it works out. Yeah. Okay, so what's this? It's that the for each symbol function is expecting a bool return value. Well, I should just convert this to my new thing anyway. Iteration decision import. I'll say iteration decision continue. And then there's somewhere else where I was using this. So for each symbol, wait, what the heck am I doing? Oh, it's up here. So I like using these very explicit names for deciding what to do in one of these for each functions. So I have iteration decision abort or continue, just tells you if the for each thingy should like keep looping after this callback returns. I find it slightly nicer than using a boolean. Okay. So ID exited, and we see here ID, and I don't know why this is on the list here, but whatever. LS, that's all good. Let's exit from my GUI app. See that we are in exit, and then there's G application quit, and start. So this all looks good. Of course, this is like a C++ mangled name, but I'm not gonna write a name demangler in this this video. But I will probably go and make one eventually, because it would be nice if this would show up as like G application : quit. But this is actually rather cool. You can see the offset into the function even. What happens if we do something that would crash? So like there's this bug, for instance, if you open proc self in file manager, then we don't get any symbols. But are these valid symbols in the file manager? 878704. Yes, it's in exit. So why doesn't it find this? Let's see. Sims elf loader. So are we here? No elf loader? Or are we here? Huh? Proc self. No elf loader. No elf loader. So who prints user space? Says an assertion failure in user space, which we'll call abort, which we'll call exit 253, which should really be sending a signal abort to ourselves, but whatever. This is currently doing exit, and this was indeed exit, but why doesn't this process have an elf loader? That's so weird. Loader. So how the hell would we be in a process with no elf loader? I wonder what this... does it have any other threads? No, just the one thread. This is exit. So exit, first thing we'll do is just call dump backtrace. I guess we can do here. Exiting elf loader is have an elf loader pattern. Okay. Just to verify that I'm understanding this correctly, that there is no elf loader. Because it's fine for a kernel task to not have an elf loader. But for a user space program, that's strange. Elf loader. Okay, elf. Oh, let's print out when we assign these so we can figure this out. Name, mpid, and elf loader. Proc self. So file manager, do exact. Oh, hold up. I see what's happening here. So it's trying to exec proc self. Well, that doesn't make any sense. So then what the heck happens after that? I guess file, oh, this is a curious problem. So it's not just that we're crashing in File Manager, we're trying to execute the file because I'm double clicking on it and it doesn't realize that it's a directory. So where the hell is this code? Directory view. So let's see. If it's an executable, which it will be because directories are executable, we'll just try to execl it. And then we assert not reached. So I guess we're here. So we're forking and then we assert not reached. So after we fork, we don't have an elf loader. Oh. That's interesting. Wait, so what happened to them? Well, this is like, yeah, it doesn't crash the File Manager. I see now. Okay, this is something that's kind of out of scope for this issue. So I knew about the crash here, but I never really looked into it. Well, let's make something crash in a more sensible way. So let's say, I guess if you type a bad character into the terminal, so like if you say that you type a P, because P is terrible, we'll just crash. Okay, so then I'm typing ABC and then P. And an invalid opcode. Yeah, right, because it's not the crash, it's the exit thing that prints the backtrace. I'm stupid. But we should probably make that thing do a backtrace as well, but not right now. I just want to see the freaking backtrace. So A, B, C, and P. And what did we get? So up here, we now have the kernel functions, and then exit, and then terminal onchar, terminal whatever this is. I don't even know what the heck that is. Can I demangle that? Oh, it's a lambda in the constructor. Well, I think that's cool. And then we could see the shell dying down here too in line editor get line. Very nice. Okay, so I think that this is essentially working, but that file manager issue, it's just there's already a GitHub issue about that, so I'm not gonna delve into that in this video any more than I already have. So let's do a patch review. First thing is we should probably remove the bad character here in the terminal. Okay, so in elf image, we are now changing this for each symbol helper to use the iteration decision enum. And then an elf loader, same thing here, iteration decision. And here's the new function, elf loader symbolicated. So let's see what it does. So what it does is, if we don't have sorted symbols already, then we will iterate the elf image symbol list or table and append all of them to the sorted symbols vector one by one, and then we quicksort the sorted symbols vector so that they are in order, which allows us to search through it here. And then we look for the symbol that we look for the address that we've been asked to symbolicate, and if we find it, then we just return a string with the name of the symbol plus the offset into the symbol that this address represents. And if we don't find anything, we say question mark. Okay, and then here's the declaration for that. Here's the sorted symbol struct and the vector. So I guess like it is a bit sad that like, or maybe it's not sad, but like once you symbolicate anything in a process, then it will have this cached, basically. Well, we use up some kernel memory, but I think it's probably not a big deal. Okay, and then in ksims, if we don't find a kernel symbol for a given address, then we will check, does this process have an elf loader? If so, we ask the elf loader to symbolicate the address and just print that. Otherwise, we print this, and I guess we should remove this weird thing, but the no elf loader can maybe stay so that I understand what that is. No elf loader, yeah. We can actually say no elf loader for process. Okay. And then in process do exec, when we load the elf, we now put the loader aside instead of just doing it on the stack and then losing it. We put it in an own putter, so it's on the heap, and then we just go about our business like normal, except when we're done loading, then we stash away the elf loader. So that's here, and we don't need this debug printf. But yeah, so now from now on we have an elf loader cache for this process, and then likewise in sysexit we don't need to print the elf loader. So yeah, so here after we stash away the elf loader, then it's accessible now through the elf loader getter on process, and it's stored here as long as the process is alive and keep the elf loader. And let's just see what's in the elf loader so that we're not bloating ourselves up. So the elf loader is how big? It's 48 bytes. Thank you, Qt Creator. 48 bytes, that's not bad. Elf image is what, 16 bytes? Yeah, so it's like a little, this vector here and little hash map for the sections, so it doesn't matter. Okay. I think that's cool, so let's commit this. Let's say kernel symbolicate userspace backtraces. Using the elf loader. Stash away the elf loader used to spawn. User space stack addresses later on. This should make debugging 78 characters. I'm always trying to stay within. This will make debugging user space programs a lot nicer. Okay. And push. And let's see it one more time. Do I still have that P thing? I do. Look at that, it's so nice. Let me exit the process manager. Boom. Very cool. Okay, so I think I'm pretty happy with that. So I'm gonna end the video here. So if you made it this far, then I thank you for watching, and I will see you next time.